So today we are starting 1.1c scatter plots and regression models. Please excuse me on some of my notes. I write scatter plots as 2 words. Some of them it's 1 word. I think it's 1 word. I'm pretty sure it's 1 word, scatter plots. I think it's 1 word. And so sometimes, I don't know what I did, but know that I know it's 1 word, okay? Blame it on the medicine. So we're going to start with scatter plot review. Do you all remember doing scatter plots anywhere between 5th and 8th grade?
No.
Yes, roughly, vaguely. Okay. Scatter plots are when you're given a set of data and you have to determine, starting off with linear wise, whether it's what type of linear correlation is there. Okay. So what I want you to do is I'm going to give you, is 3 minutes fair enough at your tables to go through 1 through 4 and 5 through 8 to determine whether it's a linear, positive linear, negative linear, constant, or no correlation. Okay, we'll do one together just to make sure we're all on the same page. How about that? So if we look here at number 1, it says we have total haircuts given compared to total income dollars. So clearly, the more haircuts I give, what happened? The more money I make. So this is a trend line of doing what? Is it going up? Yeah. Yes, so it's a positive linear. Why is it a positive linear? It's increasing from left to right in a steady linear fashion, right? Okay, so all we're identifying if it's a positive or negative or no correlation linear. So just reviewing, positive linears, the data overall increases from left to right. Negative linear, the data overall decreases from left to right. Constant, the data overall stays around the same value. Or no correlation is saying that it makes no line. There's no line being formed. Does that make sense? So no correlation means no line or relation of a line. No line being formed, okay? So I'm going to give you, I think we can do it in 90 seconds. Roughly? No? Yeah, 90 seconds. We'll see where we're at. Maybe. Okay. While you're doing this, keep in mind the words outlier. Does that ring a bell? In the scatter plot? Think about it. All right. So let's go for 90 seconds and see what happens. And go. All right. So number 2, what do we decide? Is it a positive linear correlation though?
Yes.
No, it is not linear. This is non-linear. This is no correlation. This is no correlation as a linear. However, there is a type of correlation. Can anyone figure out what that was? It is exponential. It would be an exponential though. But are we talking about exponential? No, it asks for what? Linear. Okay. What about number 3?
Constant.
We put a constant. And why did you say constant?
At the same as the line.
So the values are staying roughly around the same? I can say constant. Okay, what about 4? Did anyone feel like 4 was a toss-up? Or we said no correlation? No correlation? I would agree with no correlation. Now, I would also give you some credit if you said constant, but because you acknowledged that there was outliers. Does that make sense? So if you say it's constant, however, there are a few outliers that may make it no correlation. Does that make sense? So if you justify it, guess what? I can work with that. All right. All right, 5. What did we decide? On the back. We said positive linear. Good job. Okay, what about 6? No correlation. This is not a linear correlation. Anyone know what it is? You got it. Yeah. Yes, perfect. It is a quadratic. All right, what about 7? I would have rolled the positive linear too. All right, and 8. Ooh. And what makes it positive linear? But you have to point out the what? There are a couple outliers that interfere with that, right? So if we take away the outliers, the general progress is positive linear. Yes? All right, questions about scatter plotting? Good to go? They keep going? Awesome. All right, now, what if I have data, but no scatter plot? What do? I make one. I make the scatter plot to determine what type of relationship I have. Does that make sense? So guess what we're gonna do? Oh my gosh, we're gonna make our scatter plot. So in your do now, you needed a calculator, and hopefully you got one. And so we're gonna start with our method 1, which is using our TI-84. So our handheld calculator. So the one that looks like this, it says TI-84. This is going to be page 10 in your handy dandy notebook. When you put it in your notebook, it is meant to either be able to fold it in half, so you can have access to it, right? And be able to, here's my steps, here's my example. Does it make sense? All right. So we're going to start off with the National Weather Service uses a chart to determine the wind chill factor at various wind speeds. Wind chill is the cooling effect caused by wind blowing on a surface. This phenomena explains why you can feel colder on a windy day than on a calm day, even if both days have the same air temperature. The following table shows the air temperature in degrees in Fahrenheit and the corresponding wind chill factor, the temperature in degrees Fahrenheit that chills when the wind speed is 20 miles per hour. Okay, so basically what this is saying is I'm standing outside, and on these various days, the outside temperature is 40, but there's a 20 mile per hour wind chill happening, right? And it's going to make it feel like it's 30. Does that make sense? It's going to feel colder. Or it's 35, and that 20 mile per hour is happening, and it's going to make it feel like it's 24. Have we all felt that before? Okay, that's some serious wind, right? Some serious wind coming at you. Go get some chapped lips and chap other things. Okay, so it wants us to determine the equation of the regression line. So we first are going to determine what type of equation regression are we going to have, and we need our scatter plot to do that. So we're going to learn how to do it in our handy dandy calculator. If you are a good person, good at following steps, you can work ahead. If you are not good at following steps, you can follow along with me. Okay. All right. So we're going to grab our calculator. I'm going to grab my handy dandy calculator. Calculadora. She's right here. I'm going to reset it. So I'm going to press second plus 712. That's what step number 1 tells me to do. I'm going to press second plus 712. Second plus 712. Second plus 712. Okay. All right. Now that I've reset my calculator, what does step number 2 tell me to do? I'm going to enter the stat editor. To get to the stat editor, I'm going to go to stat. The stat button is below the delete button. So I'm going to press stat, and I'm going to go to edit. Okay. Once in edit, I'm going to determine which values to put in. So L1 is typically your independent. So it's going to be my X. So this is my independent. L2 is going to be your dependent, your Y. So I'm putting this guy into L1 and this guy into L2. All right. So I'm going to get to typing my numbers in. Cool. So I have 40, 35, 30. You guys will probably get your numbers in faster than me because believe it or not, it is not quite easy, fast typing, pressing buttons with buttons. And now I'm going to put in my 30, 4, 17, 5, 32. All right. Are we all in? All right. So after we've done that, it says we're going to select, we already put it in. We're going to go to step 5. Because I didn't say 4. I didn't say my steps out loud. My bad. We're on step 5. We're going to press Y. So the steps that I'm following, in case you're wondering, right here. So we've already did this. We entered our data. We're on step 5. It says you're going to press Y equals an arrow up to plot 1. Press enter and arrow down to turn on the plot. So I'm going to Y equals. I'm going to arrow up to plot 1. Press enter. And I'm going to arrow down to see that my plot 1 is turned on. Do you see how my plot 1 became bold? Yes, yes, yes. All right, what's our last step? We're going to press zoom and then zoom stat. So zoom and then zoom stat is going to be 9. So we're going to press 9 and ta-da! Here's your scatter plot. Oh my gosh, mind blown. Whoa, 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 whoa. I know. All right, based on what we have here, what type of graph do we have? A positive linear. Look at that. So we know that we are determining the equation. So we are looking for a positive linear. Was that terrible?
A little bit.
It was a little bit. Okay. All right. So when you have 2 points, to find a linear equation, it's what you did in your 1.1b, right? You're going to find your slope, then plug in a point in your slope and solve for y, right? However, when there's more than 2 points, it's a little bit more of a process. That process is called a regression model, okay? We're not going to do the regression model by hand. We're going to let the calculator do it for us, okay? So the steps that we're going to follow next are linear regression model steps, okay? So these are the steps that we're going to follow. Now, step 5 is 100% optional. I like step 5, but you may not. Okay. Step 5, what step 5 is going to do is it graphs it for me automatically on the calculator. And I like that feature. If you don't, then you can write it and do it yourself, right? You can go and type it out yourself. I don't want to type it out myself. I like that it does it. Okay. All right. So we're going to go through these steps to get our equation. So now it says we're going to press stat. And we're just going to go back to the editor, because if I didn't have points in there, I would make sure I have to put them in there. Are my points already in there? Yes, so we're good to go. We're going to go to second mode. What this does is it returns us to our calculator page because we're ready to calculate something, right? We want to calculate the regression model. So we came back to our calculator page by pressing second mode, okay? Now we're going to go stat, calc, and we want to find our linear regression. So we're going to go to 4 lin reg. Do we all see 4 lin reg? Gonna press that. Now, what did I say about option 5? It's optional. Step 5 is totally optional. I'm going to model it for you. If you don't want to follow it, then you can go ahead and step 6 and get your answer. Does that make sense? All right. So what this is telling you at step 5 is you're going to press vars. You're going to arrow over to y vars. Arrow to y vars. You're going to press 1 for function and 1 for y. 1 for function, 1 for y, and then you're going to go down to calculate. I'm going to hit enter. It's going to do some thinking. And ta-da! It has found my slope and my intercept. So can I write my equation? Yes. So my equation for this problem is y equals 1 and 29/100 x minus 21 and 51 hundredths. And that's the line. Now, let me show you what the beauty of step 5 is. When I click on graph, because I did step 5, look what it already does for me. It draws it in there for me, which I think is useful. Did y'all do step 5 along with me? Oh, if you didn't do step 5, this is what happens with step 5. Okay. If you didn't do step 5, you would have to go to Y1 and type in yourself. But because I did step 5, what did the calculator do for me already? It did it for me. It types it in for me. Just by doing that added little step. Is it necessary? No, but it's savior and I like it. Okay. Did you do step 5? You sure?
Can you re-go over step?
I will. So I went stat, calc. I'm doing all the steps. So I have to do them all over. So stat, calc,
And then
4.
Okay.
Then I came down to store.
Okay.
And we went vars, y vars, function, y1. And then calculate. And that's how it ends up graphing the line for you. Okay. All right, so now we have our slope. So our slope for this problem, it says, what is the slope of the regression line and what does it mean in context? Well, our slope is 1 and 29/100. What does that mean? What is this? What does slope mean? It's your what? It's our rate of change between our what? For this problem. There we go. So our 129 is rate of change between our air tip and wind chill. Our wind chill tip. So the higher the air temperature, the higher the wind chill temperature will be. Does that make sense? It's a positive change, right? So they're increasing together, right? All right. Then it says, what is the dependent variable? Well, what was our dependent variable? Dependent is your y. So what was our dependent variable? Our wind chill. So that was our wind chill tip, and it's dependent because it depends on, it's our air temp, right? Because it depends on our air temp. Okay. Last question, it says, use the equation of the regression line to estimate the wind chill factor for a 32-degree Fahrenheit day with the wind chill of 20 miles per hour. Okay. So what this is telling us is that we are given our X, right? This is our X. So if I'm giving you your X and we have our equation, all we're doing is to do what with this X? We're going to replace it. We're going to plug it in, right? We're going to substitute. So what we're looking for is 1 and 29/100 times 32 minus 21 and 51. Now, the beauty of step 5 is that if I have this already in here, guess what I just have to do? Go to the table. If I already have it in there, I could just go all the way down to 32. Or does anyone remember from their scavenger hunt how to go to 32 without having to scroll all the way down? Table settings. So I got to go second window, and I want to know the value of 32. So now when I go back to my table, guess where it starts? At 32. And what would be my wind chill factor if it's 32 degrees? 19.8. Yes, 19.8. Do you need me to zoom in on something? Good. All right. So this was method number 1. Is it terrible?
No,
Did you actually have to do a lot of calculating? No,
no, but it's hard to a lot of stuff.
you got to practice it, right? It's something you have to practice, okay? With method number 1. All right.